Hey guys, it's Nitin from FTC Team 18172, Uplift Robotics, and this video is going to focus on assembling the US Digital E4T optical encoder. If you haven't seen our previous video on odometry in FTC, then go check out that one as well, since this video builds off of the previous one. Before we get into this video, we want to thank US Digital for sponsoring our team and this video series, and without them, we would not have been able to create this video. We put some links in the description to their products and particular ones that we used in some of these videos, so go check out some of their amazing products. Okay, so the E4T encoder comes with 4 main parts and some extra tools and screws for assembling the encoder. There's the encoder base that mounts to whatever surface your design calls for. There's also the printed circuit board, or PCB, that contains some of the vital electronics, including the optical sensor. This optical sensor tracks the optical disc that contains a varying number of marks for the sensor to read, but I'll touch on this in a little bit. After all that is done, the encoder cover is used to enclose the sensitive components within the encoder. These 4 parts have a lot of different options to configure based on your needs, so let's take a look at some of them. Alright, so there's many different encoders that are popular within FTC, but we're going to stick with the E4T encoder in this video. So on the US Digital website, they have a lot of configuration options, so I'll take you through a couple of them. The first configuration option is the CPR, or the cycles per revolution. This is basically the number of readings that the optical sensor can read from the optical disc within one rotation. So the higher the CPR, the more precise the reading, and the higher RPM that the shaft can spin while being accurate. There's a wide range, but the higher ends will be slightly more expensive. Our team chose to go with a 720 CPR, but anything above 360 is a good benchmark for an odometry system. The next option is the bore size, and this is dependent upon your shaft diameter for your design. So in FTC, this is most likely either 6mm or a 1/4 inch, but there's a few smaller options as well if you need. For the output, we recommend sticking with the single-ended, as this is plenty for FTC, as long as we use shorter and covered wires to protect from ESD and other electrical outputs. The cover has 2 options, one that encloses the shaft and another that has a hole for the shaft to go through. The default option will limit the shaft to somewhere between 0.275 and 0.395 inches, whereas the hole will let the shaft pass through the encoder and have an unlimited length afterwards. We recommend the default option to protect the internal components of the encoder from any kind of dust or any other particles. The screws that come with the encoder are either 3/48, 3/16 long, or M2.5 4mm long. For the odometry system, this might be too short, so we recommend getting screws from your local hardware store, but just in case, choose your either metric or your customary standard. Packaging in bulk will reduce the price since you only need one of each tool anyway. Once you finish all of the options, there should be a product number down here where you can enter in a product number if you already have the configuration. Down here you can also download the CAD files for your configuration and also look at the pricing based on your configuration as well. For the encoder wires, there's several options, but we recommend going with the sheath since this will help give extra insulation to protect the wires. We left the product numbers for the encoders and wiring that we used in the description as well. Alright, so let's jump into the fun part in assembling the actual E4T encoder. Once we finish assembling the US Digital E4T encoder, this should be the final product. You can see the encoder port right here for the wire, and if you spin the wheel, the encoder should be able to read the rotations from this axle. Of course, this 3D printed mounting plate should be depending upon your own robot design, but we've created this particular part for our team's robot. So the first thing you'll notice before I even get into assembling the encoder is that I have these gloves on, and that's to protect the sensitive components of the encoder. Okay, so the first step is to take the encoder base and mount it onto whatever 3D printed bracket or some other part. So in this case, we've actually used slightly longer screws from our local hardware store in order to mount the encoder base and then use some nuts on the other end. Now that I've gotten the encoder base mounted onto the 3D print part, I'll cut back and assemble the axle and the wheel. Okay, so for the second step, we're going to take the PCB right here in this ESD bag. So this PCB is actually really sensitive. In order to chip them off and put them into your encoder, all you need to do is just flex that edge right there, and if you give it enough strength, you should be able to break it off. So this might take a little bit of force. A little bit of. Okay, there we go. So once you get it off, be really careful not to touch this right here. That's the actual optical sensor. So you want to be careful with that piece. Right now I'm holding it from the encoder port since that's a lot safer than the other end. And then I'll put this, the rest of the pieces back into the bag. Okay, so now I'm going to take the PCB and take the 2 pins on the encoder base and align them with the 2 holes on the actual PCB. So I'm going to take this and align it how I want it. So I want this encoder port to be facing on the top. So I'm going to take it right here and align the holes with the pins, and it should snap on. And now, just for aligning the PCB and the encoder base, we're going to take this spacer tool, which should come with the encoders, and then press down on the PCB. So that should just align with this shaft. I should just align with the shaft, and there are 2 holes. So I'll go ahead and press it like there. Alright, now that we've got the PCB on, next step is to take the optical disc. So I'm going to set this down and grab the optical disc from this tray right here. So when they come packaged in bulk, there'll be multiple optical discs. So go ahead and open this tray up. And grab this optical disc, but be really careful with the optical disc since this is also really sensitive. You want to make sure that this optical disc is perfectly centered onto this axle before you press down with your centering or the spacer tool. So I think that's good enough. So I'll go ahead and grab this, grab the centering tool, and once again, I'm going to press down. Once again, take these 2 holes on the centering tool, or the spacer tool, and press down on the encoder. And it should be nice and quick. And that should be able to grasp the shaft really well. So you'll see that there's very little space on the top. Now the next step is to finally take the encoder top cover and assemble it onto the encoder. So you should be able to align the cover with the 2 pins on the side, and those should be able to snap on. So you should be able to feel 2 clicks. Once you get the end caps on, you should have the encoder fully assembled, the port just like I showed earlier, and the insides of the encoder should be fully sealed from any dust or any particles that could potentially damage the optical sensors. So that's it for assembling the encoder. Once again, thanks to US Digital for sponsoring our team and this video series, so be sure to support them by checking out some of their products. If you have any questions about these encoders, let us know by contacting our team through our social media in the description or leave a comment down below. Thanks for watching and stay tuned for more videos.